Physics Part 139. More on series and parallel circuits. At the end of this section, you should be able to derive, using Kirchhoff's laws, a formula for the combined resistance of two or more resistors in a series. In series, you should be able to solve using the formula for the combined resistance of two or more resistors in series. You should be able to derive using Kirchhoff's law a formula for the combined resistance of two or more resistors in parallel. Solve problem using the formula for combined resistance of two or more resistors in parallel. You should be able to apply Kirchhoff's laws to solve simple circuit problems. You should be able to show an understanding of the use of potential divider circuit as a source of variable PD. You should be able to explain the use of thermistors and light-dependent resistors in potential dividers to provide potential difference which is dependent on temperature and illumination respectively. You should be able to recall and solve problems using the principle of potentiometer as a means of comparing potential differences. Resistors in series. Well, the figure shows two resistors in resistance R1 and R2 connected in series and a single resistor resistance R equivalent to them. The current I in the resistance and in the equivalent single resistor is the same. The total potential difference V across the two resistors must be the same as that across the single resistor. If V1 and V2 are the potential difference across each resistor, V is equal to V1 and V plus V2. V is equal to V1 plus V2. But since potential difference is given by multiplying the current by resistance, IR is equal to IR1 and IR2 dividing the current I, R is equal to R1 and R2. This equation can be extended so that the equivalent resistance R of several resistors connected in series is given by the expression R is equal to R1 plus R2 plus R3 plus blah 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 blah. Thus, combined resistance of the resistor in a series is the sum of all the individual resistance. Resistors in parallel. Now consider two resistors of resistance R1 and R2 connected in a parallel as shown in the figure. The current through each will be different, but they will each have the same potential difference. The equivalent single resistor and resistance R will have the same potential difference across it, but the current will be total current through the separate resistors. By Kirchhoff's first law, I is equal to I1 plus I2. By using Ohm's law, I is equal to V over R. So VR is equal to V over R1 plus V over R2. Dividing by the potential difference V, I over 1 over R and 1 over R is equal to 1 over R1 plus 1 over R2. This equation can be extended so that the equivalent resistance of R of several resistors connected in parallel is given by 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus blah 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 blah. Thus, reciprocal of the combined resistance of the resistance in parallel is the sum of the reciprocals of all individuals' resistances. Note that for two identical resistors in parallel, the combined resistance is equal to the half of the value of each one. Number two, resistors in parallel and combined resistance is always less than the value of the smallest individual resistance.